Well, I want to show you some calculator things before we start anyway. So this is a question out of the homework. So it says each of these represent a geometric sequence. Find the first term. So the easiest way to think about this, so if I'm just doing A, I have like the fourth term is 135 and the seventh term is 3645. And we're told this is geometric. So I showed you how to do this by hand last class, but we can do this just all entirely on our calculator. So I'm going to think about these guys as points. So the point is like the n comma a sub n. And I'm going to do stat. From the edit tab, I'm going to pick the edit command. I'm going to clear my self a space in L1 and L2. And I'm just going to type the x coordinates into L1 and then the y coordinates, the corresponding y coordinate anyway, into Y2. So far, so good. And remember that an a geometric sequence, which is what this is asking for, is the same as like an exponential equation. So what I'm going to do is I'm going to do stat calc, and then I'm going to do the exponential regression on those 2 points. And I'll hit calculate here. So I have the equation like a sub n equals, it was, what was that, 5/3 times 3 to the x, or I should say n. Does that feel okay? Well, you're not going to get an exact answer if you did a decimal. You know what I mean? So if I want then the first term, I just plug 1 in for that, and I get 5. The question asked for the first term. That's why I did that extra piece at the end. If all you needed was the equation, though, or the nth term or whatever, the regression equation is all you need. But that's super helpful, right? Like the algebra to do this is kind of a hassle, where you have to solve that system by dividing the equations and stuff. That's not a whole lot of fun. This is super safe and super easy. Could you do the same thing if it was the same question they asked for an arithmetic sequence? Yes. What would you do? I just, instead of doing exponential reg, I do a lin reg, because arithmetic is the same thing as linear. Geometric is the same thing as exponential. So you could certainly do an equivalent question that asked for an arithmetic, or told you it was an arithmetic sequence. You can do the same idea, just lin reg it. And again, on the IB exam, are they looking for shown work? Not really, right? So if you just like write your system and then just type it in your calculator and get the answer, that's good enough, right? So I definitely wanted to show you guys that because that's helpful. Yeah. Sure. So what I did here to start, Luke, is I counted out what term number each of my two given terms were. So the fourth term was 135 and the seventh term was 3645. So I thought about that as the 0.4 comma 135 and 7 comma 3645. So to get those into my calculator, I press Stat, and then from the Edit tab, I'll pick the Edit command, and I'll type the X coordinates into L1 and the corresponding Y coordinate into L2. Once I've got those in there, I'm going to exit out to the main screen. So second and the mode button. I'll go back to the stat menu, but this time I'm going to go to the calculate tab. And what I'm looking for is since it's geometric, I want the exponential regression. So EXP reg. The X's are in L1, my Y's were in L2, so that's good enough. I'll just hit calculate. And that spits out my equation, right? It tells me that my equation is y equals a times b to the x. My a is 5/3. My b is 3. So that's allowed me to write this equation. And then if I wanted, say, the first term, I just plug 1 in for n. And spits right out for me. Does that feel okay? If the problem had said this was an arithmetic sequence, I can do the same steps, but instead of using a lin reg, or instead of using an exponential reg, I can use lin reg. And it'll work the exact same way. Yeah, Alessa.
This is kind of random, but for like quiz, will we have like the base equations for geometric like
Yes.
Okay, since there are only the two types from the base.
Yeah, let me just. Yes, sir. Let me double check here for you real quick. Yes. The base equations would be given to you. All right, should we close this chapter down here? We ready to do so the series? Okay. So let's say that I have the sequence So for sequences, usually we use like a lowercase a or u or b or something. For a series, we use like a lowercase letter s. And a series is just going to be the sum of the terms of some sequence. Now, if we are only interested in a finite number of terms added up, like if I just want the sum of the first 5 terms, we call this guy a partial sum. because it's only part of the entire series. Now, if the sequence that we're adding up is arithmetic, we'll call that an arithmetic series. If the sequence that we're adding up is geometric, we'll call that a geometric series. Everybody's okay with that idea? So remember we talked about like geometric sequence? So if the terms are to go from one term to the next, if it's via multiplication, so like each of these is times 1/2, so I would recognize this as geometric. So this down here would be a geometric series because it's built on a geometric sequence, because to go from one term to the next, we multiply by 1/2. Does that feel okay? Okay. Now, in general, this is fine the way we've written these series, but you imagine if we're adding up the first 7,000 terms or something, I don't want to have to write that all down. So we want a notation to kind of represent, okay, add up the first like 15 terms of the series, so I don't have to write out 15 numbers being added together, because that's kind of obnoxious. The way we do that is using something called sigma notation. So if I have some series, and I'll just say like that, and I have the series then, I could write it like that, right? Or the more compact way of writing it is using this capital Greek letter sigma. So that big E looking thing is the capital Greek letter sigma. So it just means that we're going to be adding things up. The thing next to the sigma is what we're going to be adding. So in this case, we're going to be adding a sub i's. The I underneath the sigma is the index variable. And we'll write equals a number, and that number is going to be the term where we start our addition. So in this case, we're going to start adding with term 1, which is what we've drawn here. And the number on top of the sigma is where we stop our adding. So that's going to be term 5. So this sigma notation is saying that we're going to add up the terms 1, 2, 3, 4, and 5. And it's just a way of writing that same sum that I wrote here on the left in a more compact way. Does that feel okay with you guys? Let's do some examples of kind of moving back and forth between our sigma notation and an expanded form and an expanded form in a sigma notation. So let's say we wanted to write, or we have the sum of I squareds from I equals 3 to 6. So what this is going to tell me, we're starting where I is equal to 3. So I'd have 3 squared. And then we're going to go until I equals 6. So then I'd have 4 squared, 5 squared, 6 squared. Is everybody okay with how I went from the expanded form, or how I got that expanded form? So this is just telling us what we're plugging in here. So we start plugging in 3 and we end plugging in 6. We just increment up by 1 each time. Everybody's okay? All right. What if I have like this expanded form, and I want to rewrite that as a sigma notation. So first thing I'm going to do is look to see if it's obvious what's changing. Is it obvious to see what's changing from term to term? What's changing? The exponent. What is, so the thing that I'm adding up is going to be 3 to the I then, right? Where that 3 stays the same, the I is the thing that changes. Everybody feel good? Where does that, where does the addition begin? Okay, and where does it end? Looks pretty good. Do you guys feel okay doing this? Going back and forth? Again, it's not like incredibly complicated, but if you don't understand what you're looking at, you know, it can be tricky. Let's do this example here real quick. So here it says evaluate. What is that going to mean that we need to do? We want to expand it, and then we have to do the actual addition to get a number. So this answer is just going to be a single number, right? Okay, so let's write the expanded form first. Where do we start at? 2 to the 0. Mm-hmm. Great. That looks fantastic. So into my calculator I go, and this seems kind of annoying, right? I'm not going to write 2 to the first. I'm just going to write 2. Everybody's okay with that, I hope. What if I told you that there was going to be an easier way than this of doing an evaluation problem on your calculator? Would you be interested? So that comes out to be 63. Okay. So alternatively, what if I told you that I can just type this thing into my calculator and press enter? Sounds pretty nice, right? Yes, Mr. Kulik, please tell me how to do this. So to do this, I'm going to press the math button, and I'm going to scroll down to the bottom. What I'm looking for is the summation command. So I'll press enter there. And now I'm just going to make what's on my calculator look like what's down here, except instead of using n for my index, I'm just going to use the x. Yep. And then you just type it the way it looks like on your sheet of paper and press enter. And that's pretty slick, huh? It's like, I like that, Mr. Kulik. What if I had, for example, asked you to what if I asked you to evaluate this series, 1/2 plus 2/3 plus 3/4 plus 4/5 plus ... 99 over 100? Do you think I want to do this by hand? No. What am I going to do? Well, what I want to do is I want to write this into summation notation, sigma notation, so I can enter it in my calculator and press enter. Sound good to you guys? So the first thing I want to do is try to figure out the function that goes here. So if I look at each term of this, how are the terms changing? Can we figure out a formula here? Nope. This is going to be just looking at it in our heads. So when I look at this, 1/2 looks like 1 over 1 plus 1. 2/3 looks like 2 over 2 plus 1. 3/4 looks like 3 over 3 plus 1. 4/5 looks like 4 over 4 plus 1. 99 over 100 looks like 99 over 99 plus 1. Now, if I write it that way, is it clear what's changing? It's those numbers each time, right? Everybody agree? So that's going to be my I. Everybody's okay with that? What is I starting at? 1. And what is it ending at? So that's what I'm going to type into my calculator. So math, summation, x equals 1 to 99. And then I'm going to do alpha y equals, and I'm going to do the fraction command here to make that x over x plus 1. And then press enter. It'll think here for a minute. tells me it's this, and I'll say, is that a fraction? It says apparently it doesn't want to give it to me as a fraction. So 94.81 or something. I'll just go with that. What do you guys think there? Was the hardest part getting that, right? Figuring that out. Not really a set way of doing that. But the way I would, what I noticed to start with was if I look at just the numerators, they're going up by ones, starting at 1. If I look at just the denominators, those are going up 1 at a time, but they started at 2. So I'm like, oh, okay, well, we're just adding 1. It's like basically 1 over 1, except I put an adding 1 in the denominator, and like 2 over 2, but I have to add 1 in the denominator. So that's kind of what I thought about to come up with the formula. So if you have a fraction, and it's obviously not arithmetic or geometric, like this one is clearly not one of those guys, right? That's what I would do. So a couple of properties. If I have some value that doesn't depend on that variable, the index variable, I can pull that value out front and just deal with the k times whatever that sum is. If I have the sum of the sum of 2 or more things, or the sum or difference of 2 or more things, basically this summation can just kind of distribute. And I can do each sum separately and then take the answers and add them together. Or subtract them depending on what it is. So those would be the 2 big ones that might be useful. So this formula I can use to find like the nth partial sum of an arithmetic sequence. So it's going to be the first term plus the nth term divided by 2 times the number n. Beautiful formula. If my sequence is infinite, what do you think that's going to be? It's going to be either positive or negative infinity. The word we use in mathematics is we say that's divergent. Or we'd say that series diverges. But that's true for all arithmetic sequences. Scroll here. Just the there it is. I want to make sure I had that. So for the nth term, or the nth partial sum, for a geometric sequence, I can calculate that by just taking the first term times 1 minus r to the n divided by 1 minus r, where r is that common ratio, right, for the geometric. That's that factor that you're multiplying by each time. And if this is infinite, you actually get two possible results. So sometimes you have an answer if r is between -1 and +1. Otherwise, it's divergent. Okay, so let's run through some examples here. So it says, consider the arithmetic series containing 50 terms. It says to begin by write the series using sigma notation. So the first thing I'm going to do is consider the sequence. I can see that it's arithmetic because I just add 5 each time. So I know the D for this is 5. And then I remember the formula for an arithmetic sequence is a sub n equals a sub 1 plus n minus 1d. So my a sub 1 is 3, and my d is 5. And if I simplify this down, I'm going to get 5n minus 2. Does that feel okay with you guys so far? So to write this, then I'm going to say this is the sum from I equals 1 to, I know there's 50 terms, so 50 of 5i minus 2. So again, the hard part was getting the sequence in there. Joey? No, we put 1 because when I plug 1 in for I, 5 times 1 minus 2 is 3. So I don't write the term value, I write the term number as where to start. Does that feel okay? Okay. Part B then says find the partial sum for the first 50 terms. So S sub 50, again, using our formula, is going to be the first term plus the 50th term divided by 2, and then times 50. We know the first term is 3. To get the 50th term, all I need to do is plug 50 in for I. And when I do that arithmetic, I get 6275. Or alternatively, what could I do? Into my calculator you go, right? Is either fine? Yup. On my test or quiz, if you enter it in your calculator wrong, will you get any partial credit on it? No. I would suggest at least like doing a little bit of the setup, even if you use the calculator to get the final answer at the end. Use it as a checker more than just a means to get the answer, but show a little bit of work there, especially since all you really have to do is plug stuff into formulas. It's pretty easy. Does that feel okay on that one here, folks? All right, let's see here. Oops. Let's do another. All right. So it says, consider the sequence in figure 3.8. F1 has 1 square. F2 has 3 squares. F3 has 5 squares. F4 has 7 squares. F5 has 9 squares. Ask how many squares are in F20. What I notice is that this is an arithmetic sequence because each time we're just adding 2. Would you agree? So I'll use this to write my equation for an arithmetic sequence. And And if I want F20, oh, I guess we should call this F, huh? I'll just do 2 times 20 minus 1. So I get 39. Does everybody feel okay there? Part B, it says, is there a figure with 149 squares? If yes, which one? If not, why not? So basically, I just want to know, is there like some F that equals 149, right? Okay, well, I'm basically just going to do 2n minus 1 equal to 49, or 149. So just solve that. We'll add the 1 over. We'll divide by the 2. And because this is a whole number, that means yes, the 75th term is 149. Is everybody okay with that? If that n had turned out to be a decimal or a negative, we would say no. And the reason is because, the domain of a sequence has to be a positive whole number. Okay, what's part C says, find the number of squares in the first 880 figures. So that's going to be a sum of the first 880 figures. Oops. And if I wanted to, I can use my formula to do this, or I could use my calculator. Either one will give me the same result. Let's see, 880 times 2 is 1760 minus 1, so 1759. And if I type that into my calculator, $774,400 squares. And maybe if I wanted to check that, I could. Notice the lag here, that's real common, especially if you're doing a big sum. But there it is, matches what we got. What do you guys think so far? No big deal? All right, let's see. Just a couple more parts here. It says F1 has 4 line segments. Right, because there's 1, 2, 3, 4 sides. How many line segments are in F20? Well, let's count the number of segments here in F2. So we still had the original 4, and then we added 1, 2, 3, 4, 5, 6. If I do F3, I still have the 10 from before, and I add 1, 2, 3, 4, 5, 6, so 16. And at this point, it's pretty clear that I'm just like adding 6 each time. So I'm going to go ahead and write my formula. Oops, I guess these are supposed to be F's. So Fn is 4 plus n minus 1 times 6, or 6n minus 2. So F20 would be 6 times 20 minus 2, or 118. Feel okay there? Part E says, is there a figure with 450 segments? If so, why not? Or if so, why or why not? Blah, blah, blah. So basically, we're just looking, is there something that does this? So 6n minus 2 equal to 450. So I add 2 to both sides. And we divide both sides by 6. And I can tell immediately, just from looking at the number, that that doesn't divide. But let's convince you guys, because... Wah, wah, wah. Feel okay? And last part, F, says find the number of segments in the first 880 figures. Oops, this was not D anymore. This is E, whatever. So again, sum from 1 to 880 of 6n minus 2. Again, I could do that by hand. Let's just do it with the calculator this time, because I think at this point you guys get the idea. What do you think? You tell me, guys. How's this feeling? Is it okay, or are we too tired to concentrate? Or are we just like, I don't know, Mr. Kulik, I don't care right now? Like, is this going okay or not? Solid? Oh my goodness. 2,324,080 segments. Woo! It's a lot of segments. What do you guys feels okay so far? Let's do some geometric examples and we'll get out of here. Sound good to you guys? Yes, please. All right. It says, consider the partial sum for the first 20 terms of this series. Write the partial sum in sigma notation. So the first thing I want to do is come up with a formula. I notice that the pattern is we multiplied by 2. That tells me it's geometric, where the r is 2. And I know the geometric formula is a sub 1 times r to the n minus 1. So that's going to be 3 times 2 to the n minus 1. So my sum for the partial sum for the first 20 is going to be the sum from 1 to 20 of 3 times 2 to the I minus 1. And then part B says to find the sum. So that's going to be the first term. Let's write it out. So the first term is 3, the R is 2, and the N is 20. So I'd write that. And I'll just type it in the way it looks like on my calculator or on my piece of paper. And there's my answer. So 3,145,725. So I use the formula to that. How else could you do it? On your calculator. No. They'll be given to you. It's like, oh, Mr. Cool, like this just keeps getting easier. All right. Let's maybe do what we got. We'll do another example of this, and then I guess we have some financial crapolas to talk about. Where did you go? Yes. Okay. A ball has elasticity such that it bounces up 80% of its previous height. Find the total vertical distance traveled up and down by the ball when it's dropped from a height of 3 meters and after it bounces for the 10th time. Ignore friction and wind or air resistance. So I'm going to start by just kind of drawing a picture because this is kind of representing a physical situation. Let's be the ground. So we drop. So this is 3 meters, right? And this would be like 80% of 3 meters. And this would be like 80% of 80% of 3 meters. And we kind of just go on like this, right? So this is 1 bounce, 2 bounce, 3 bounce. So far, so good. So if I think about this, I fell 3 meters, and then I do 2 times 80% of that 3 meters, because I went up and then back down. Right, I went up it and then back down it. That's why it's 2. And then 2 times 80% of 80% of 3 meters. So this is basically like say that's 6 times 0.8 to the first, and then 6 times 0.8 to the second. Does that feel okay so far? So if I just consider this part, that looks geometric, where we're multiplying by 0.8. Is everybody okay there? So that geometric sequence is going to be, yeah, that's fine. Oops. Would just look like this, right? So we're going to have 3 plus the sum, I equals 1 to 10 of 6 times 0.8 to the I. Let's try that. Oh. Think that. No, I screwed this up somewhere. Whatever. You guys are wholly disinterested right now. All right. So the other thing that they might, or they will do as a story problem, is they'll have some financial stuff, especially concerning these geometrics. So if you took the regular pre-calc class last year, you might remember some of this stuff because I'm pretty sure we do this. So one thing we'll definitely see is annuities. And an annuity is just a sequence of equal periodic payments. It could be you paying into a loan, like money that you owe, or you making regular deposits like into a savings account for retirement. Now, if the payment that you're making is always the same, it's an ordinary annuity. And to calculate the future value for these annuities, you can use a geometric series to calculate this. So just as a quick example, if you invest like 1,000 euros, I think that's the symbol for euros, at the end of each year for 10 years at a fixed interest rate of 6%, what are we really doing? Well, initially, we've invested $1,000 and that's all it's worth because no interest is hit yet. And the next year that interest will hit and it'll blah, 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 blah. So the best way to do these types of problems is using the Finance app on your calculator. So if you go to the apps button there, the purple one in the middle, you should have an app that says Finance. And you guys will be using the TM or TVM solver. Would be the best way to do this. So like in this future example, or this example here, the N is going to be the number of years, so make that 10. The I is going to be the interest rate as a percentage. Notice the percentage symbol, so don't convert it to a decimal. The present value, well, this is a bank account that you're paying into, so there's nothing in there initially. The payment you should think about as a negative number because it's money that you're taking and out of your pocket and putting it into the savings account. So that's like a negative. And then to calculate the future value, we press alpha and then enter and then blammo. That's going to be the value after like 10 years. Well, we're putting $1,000 in. Right. Because there's nothing in the account to start with, right? And we're going to be making that $1,000 payment. So let's do some examples here, just kind of using this solver. So it says, in order to save enough money for her college education, Sophia's parents set up an annuity where they deposit $100 at the end of every month. So that payment, I'm going to make negative $100 into an account that pays 6% annual interest. So interest should be 6%. They started the year she was born. How much money will they have on her 18th birthday? So I'll make N18. And the thing we have to do here is, because it says it's every month we're doing this, the payments per year should be 12 because we're putting it in every month, and the compounds per year should also be 12. Really, those two numbers should really be the same number. And if I do my future value there, I get not the same number that the book had when they did that. Why not? Why did you get this wrong? Textbook. Why are we not even close? I'm typing in these numbers to see if this is like a me problem or a they problem. I kind of suspect one versus the other. Okay. So that's fine. So the book, oh, I bet I know. But if I do that, yeah, okay, so that was it. So the N is because 18, but it's happening every month, I had to do 18 times 12. But that's the value. Sophia's parents have saved $38,000 for her. It was a lot of money like 10 years ago. If we say have this one, you borrow $1,000 at an interest rate of 8%. So here the future value should be positive $1,000, 8% interest. You pay it back within, or you promise to pay it back within 6 months with monthly payments. So like 6 times there then, since it's every month. And our payments per month and compound per month should both be 12. Oh, I'm sorry. Let's think. The present value should be like $1,000 because you've taken it from the bank, and the future value should be 0. And then we want to find the monthly payment required. So you should be paying the bank $170.58, and it's negative because it's like you're giving that money back to the bank, right? Does that make sense? You can ignore the negative sign when you write it. Your payment is 170 point whatever. What do you guys think on this? Whatever. Great, me too. Let's be done. So your problem set 2 is going to just be section 3-4. Reminder for next time, it is the quiz from sections 3-1 through 3-3. So you should be able to, when given a sequence of consecutive terms, identify if the sequence is arithmetic, geometric, or neither. Use an arithmetic sequence to do currency exchange story problem. So you're basically just writing a linear equation and then using it to do stuff. From given information, find the nth term of a sequence, so write the formula. Whether it's arithmetic or geometric, and compute the value of a specified term. So like use your formula, then find the 50th term or something.
Could we do an example of like the last bullet point where you have like you're given 2 random terms and it's like find different ones?
Yeah. So like that would be, you know, just like this guy here, right? So like I'm told U4 is 135 and U7 is 3645 and it's geometric. So I can just use the calculator, write the formula, and then whatever the specified term is, I just plug it in for n. And
is there not like the n minus 1 in the
Correct. The calculator is not going to give it to you as an n minus 1 formula, which is fine.
Okay. Can we do one where it's like write the arithmetic equation instead of like a geometrical like that?
Sure. One moment. All right. So we're told arithmetic. Let's say that U5 is 11 and U25 is 27. And we want to find like U201 or something. So again, I'll do this all in my calculator. I might write down a little work to go with it, but of a type of question that Alyssa asked about, yes, that was listed in the quiz description. So I just set up my points 5, 11, and then 25, 27. And then I'm going to go and then linreg that. So it tells me my formula is U sub n equals 0.8 times, well, n plus 7. So U201 would be 0.8 times 201 plus 7.
Oh, what did you press like in my calculator? Because I put linreg, I got like a negative number. I think I made this wrong.
Well, probably more likely you should put the points in wrong.
Oh.
Could you do like an example of like a question that we have, please?
I mean, this is like a question that could be on the quiz. Lessa, did you type in the numbers in the right spots? Oh, did you press lnreg instead of linreg?
Oh, yeah.
Because lnreg is logarithmic.
Oh.
Linreg is like command 4 or something.
Yeah, I pressed LN right.
Yeah.
That explains why all the numbers are wrong.
Yes, because it's giving you a logarithmic equation instead of an mx plus b equation.
For exponential use, maybe for
Geometric use exponential. Mm-hmm. Yep. Is that okay?
Yes, this one makes more sense.
That's a good realization to make, that like, oh, I'm using the wrong, I'm doing a log reg instead of ln reg or lin reg,
Yes.
which is like, ooh, that's a big oopsie. All right, what do you guys say? Everybody's happy?